Welcome you all to the new session of computer graphics. Today we are going to learn the basic structure of a computer graphics program. A graphics program begins by including three header files. The first header file is graphics.h. This is included so that using our program we can do graphics operations. The next two header files are already known to you. You might have used these header files before. This is conio.h and this is stdio.h. This file and this file, these header files are included so that our program can do standard input-output operations and console input-output operations. Once the header files are included, we move on to the main function. In the main function, two integer variables are declared. One is GD and the next is GM. GD corresponds to graphics driver and GM corresponds to graphics mode. Now, what is this graphics driver? Graphics driver is a software that allows your operating system and other programs to make use of graphics hardware. And what is this graphics mode? Graphics mode indicates the number of row column divisions that your computer screen has. It is usually represented by N by M, where N indicates the number of columns in your screen and M indicates the number of rows in your screen. Clear? So, driver and mode are to be declared as integer variables. After declaring it, the next sentence is GD equal to detect. Now, this keyword is written in full capital letters. What does this mean? Every computer system has its own graphics driver and its own graphics mode. The programmer does not know anything about the computer's graphics driver and the graphics mode divisions. So, he requests the computer system to automatically detect the graphics driver in your program. I repeat, GD equal to detect is a statement which allows the computer system to automatically detect the graphics driver in your computer system. Once the driver is automatically detected, we move on to next function, which is initGraph. initGraph is used to initialize into graphics mode. Why this function is needed? We know that every computer system is by default having text mode. In the text mode, the number of row and column divisions are only few, and the text mode is capable of only displaying text data. So, along with the text, to do graphics operations, we need to display pictures also. So, to display text along with the pictures, it is necessary to convert the screen from text mode to graphics mode. Only for that purpose, we use this function. And initGraph function is used to initialize the system from text mode to graphics mode. It uses three arguments. First argument is %GD, which is the address of GD, that is the driver. Second argument is %GM, that is address of graphics mode. And the third argument is a path. You need not give any value over here. Just specify empty quotes. Once this statement is executed, the system will automatically detect the graphics driver in your computer system. Once the driver is detected, its address, the address of the graphics mode, and the path of the graphics driver are all automatically substituted in this function. So these are the basic steps every person must write in your graphics program. Once this much of portion is written, next code will help you to draw pictures. Any programmer can write the codes of his wish depending on what picture he is going to draw. So here you will write the graphics code. Once the program is written, you have to use this function close graph. Before beginning the graphics code, we used init graph function to initialize into graphics mode. Similarly, after writing the graphics code, we have to close the graphics mode. So for that purpose, to close the graphics mode, we use this function close graph. And at last, we are going to use getCH function. This function allows you to easily return from the output screen back to your program screen. This is all about the basic structure of a graphics program. Let us move on to the next topic. Let me familiarize you all with the graphics computer screen. We all know that this is an XY coordinate axis, where the horizontal axis represents the x-axis and vertical axis represents the y-axis. And this point is the origin. But when we move on to the computer screen, the origin of the computer screen is represented at this point. That is, the left top corner of the screen represents the origin of the coordinate system. And this represents the x-axis. This vertical line represents the y-axis. That means all the columns of the computer screen are represented along the x-axis and all the rows of the computer screen are represented along the y-axis. One more thing, since this is the origin, the column numbers increases when you move towards right and column numbers decreases when you move towards left. Similarly, since this is the origin, the row numbers increases when you move downwards and the row numbers decreases when you move upwards. So this is very important. I repeat it once again. The x values or the column values increases when we move towards right. The column values or x values decreases when we move towards left. The row values or the y values increases when we move downwards and the row or y values decreases when we move upwards. Okay, now let us move on to some built-in functions which will help you to draw pictures easily. First built-in function is a line function. Line function is used to draw a line. We know that this is a line and every line has two endpoints. First endpoint is represented by x1, y1 and the second endpoint is represented by x2, y2. These four values, that is x1, y1, x2, y2, these four values are to be represented in the line function. So every line function has four arguments, x1, y1, x2, y2. The first two values corresponds to the first point of the line. Next two values corresponds to the second point of the line. Let us move on to an example. See, this is an example. Line 100, 200, 50, 250. This indicates the first point is at 100, 200, where 100 is the column number and 200 is the row number. And the second point is at 50, 250. Again, this is the column number and this is the row number. In this way, you can easily specify line functions. Let me explain it with few more examples. Suppose I want to draw a line like this. Remember, whatever picture you are going to draw, the first point is of your choice. You can plot anywhere on the screen. So the first point is your choice. You can give any value, any position can be selected on the screen. So if I want to draw a line like this, the first point I selected was 100, 200 and I wrote it here 100, 200. Okay, now I am going to find the second point. But to find the second point, you have to be more careful. Let's see how. From this point, we have to move to this point. That means to reach at this end point, second point, let us examine where it lies. Compared to the first point, second point lies to the left side and we have to move downwards. Clear? So from here to reach here, we have to move downwards and then we have to move towards left. First I moved downwards and then we have to move towards left. Only then we will reach at this point. So I used two things. One, I moved downwards and I moved towards left. When we are moving downwards, as I said here, when we move downwards, the value of y increases and when we move towards left, value of x decreases. So initially the point was 100, 200. As I said, we moved downwards. So when we move downwards, value of y should increase. So y increased. And since we moved towards left, the value of x should decrease. So in this way, we can easily specify line points. Suppose I want to draw another line like this. Let this be the starting point and the starting point is labeled as 2040. The starting point is labeled as 2040. Now from this point I want to move upside direction. I am going to move in an upside direction. So from here I want to reach here. So what direction do I have to follow? I have to move upwards, then I have to move towards right. Upwards and right. Okay, so let this be the function. This is the x value and this is the y value. I am moving upwards. When we move upwards, value of y decreases. So value of y decreased. And I moved towards right side. So when we move towards right, x value should increase. X increased. So we can easily specify the first point. But depending on where and in which direction we are moving, second point need to be carefully specified. Okay, so we know these two things. Now let me tell you how to draw a horizontal line and a vertical line. First let me tell you about horizontal line. Suppose I want to draw a horizontal line. What is the speciality of a horizontal line? A horizontal line is a line whose both end points lie on the same row. Okay, so the first point, let the first point be at 50, 40. Okay, I gave it as line 50, 40. What about the second point? As I said, since it is a horizontal line, the row is same. That means the y value should be same. What about the x value? From the starting point, we are moving towards right. So x value should increase. So from 50, x value should increase, but since we are in the same row, y value remains same. So the horizontal line function can be written as 50, 40, x increased since we moved towards right and no change in y value since we are in the same row. What about a vertical line? This is a vertical line. Okay, now to draw a vertical line, remember vertical line is a line with whose both end points are in the same column. Both end points are in the same column, only the row changes. Clear? So the line function is having an initial point at 40, 50. So I specified it as 40, 50. Since this is a vertical line, there is no change in column. So x value will not be changing. Both the column x value of starting point and the column x value of ending point will be same. So x values are same. This indicates they are in same column. What about the row? Initial point was at this point, and then from this point I moved towards downward direction. When we move in a downward direction, definitely what should happen? Yes, the y value should increase. Since we are in the same row, x will not change, and since we moved in the downward fashion, y increased. So in this way we can easily draw lines. Let me explain it with one more example. Suppose I wish to draw a triangle like this. To draw a triangle, let this be the starting point, 100, 100. From this point I wish to draw a line like this. That means I must move downwards, then I must move towards left. That means when you have to move downwards, definitely the y will increase, and after moving downwards to reach at this position I have to move towards left. That means x should decrease. So from 100, 100, x decreased and y increased. This indicates we moved towards left, and this indicates that we moved towards downwards. So after specifying this line function, we reached from this point to this point. Now I am going to draw the second line, that is this line, and we know that this is a horizontal line. Remember the rule: to draw the horizontal line, both endpoints are in the same row. Now how to get this point? I am going to draw the second line from the end of first line. So end of first line is 50, 150. From that point itself I am going to start the second line. So end point of first line and starting point of second line are same. So I got this point. From this point I am going to draw a horizontal line. While drawing a horizontal line, the rule says the row is same, so y will not be changing. And since from this position I am moving towards right, x will increase. So x increased. X increased, no change in y, so the result is a horizontal line. Clear? Now once we reach this position, from this position I have to travel and reach at this position. That means from the end of second line to the beginning of first line. This is the end of second line. So the first point is 100, 150. I am going to move to the beginning of first line, that is 100, 100. So from 150 to 100, 100, 150 to 100, 100. Third line is complete. So in this way, depending on what picture are we going to draw, correspondingly line functions have to be used in the program. Next is a circle function. Circle function uses three arguments: x, y and radius. X and y together specifies the center of the circle. These two together specify the center of the circle, and this is the radius of the circle. So with just three arguments we can easily draw a circle. Let me give an example. Suppose I want to draw a circle which is centered at 100, 100. Like this. Center point of the circle is at 100, 100, and the radius of the circle is 50. So I will write the function circle 100, 100, comma 50. This means circle is centered at this point with the radius 50. Clear? So in this way we can make use of circle function. Next is a rectangle function. Rectangle function has a syntax rectangle, and it has four arguments: left, top, right, bottom. Or it is having another syntax rectangle xmin, ymin, xmax, ymax. That means instead of left I can either use x minimum, instead of top I can use y minimum, instead of right I can use x maximum, instead of bottom I can use y maximum. See, left and right specifies us the width of the the width of the rectangle. Left and right, this is the left end, this is the right end. Left and right specifies as the width of the rectangle, that is x minimum and x maximum. This is the x minimum, this is the x maximum, or left and right end specifies as the width of the rectangle. Similarly, top and bottom, top and bottom, top and bottom specifies as the height of the rectangle. Top and bottom can also be specified as y minimum, y max. So x minimum and x maximum gives you together the width of the rectangle, y minimum and y maximum together gives you the height of the rectangle. So these four values are used to draw a rectangle. So this is a typical rectangle. In this rectangle, two corner points are taken. This corner point is left top corner, and this corner point is right bottom corner. Remember, while giving a rectangle function, when you give a rectangle function, only two corner points are needed. It is not necessary to give all the corner points. With just two corner points, you can easily draw a rectangle. Okay, so let me give you an example. Suppose I want to draw a rectangle like this, whose corner point is at 50, 50. That means this point is at 50, 50. Now I am going to find the value of this point. From this point, if I want to reach this point, I have to move downwards and then I have to move towards right. So if we move rightwards, then x should increase, and if we are moving downwards, y should increase. So from the initial point, x increased and y increased. Increase in x indicates that move towards right, and increase in y indicates that move downwards. So in this way, just by specifying the left top corner point and right bottom corner point, we can easily draw a rectangle. Clear? Now, the next function is put pixel function. Put pixel function has two arguments specifying the position where the pixel is to be plotted, and the third argument specifies the color. That means this function is used to simply plot a pixel on the screen. You can plot a pixel on the screen, and using these two arguments, you are specifying where on the screen this pixel is to be plotted. So x corresponds to column number, y corresponds to row number. So these together gives you the position where the pixel is to be plotted. And the third argument specifies the color using which you are going to plot the pixel. Clear? See, I have given two examples. In the first example, I specified 100, 100, red, and in the second example, I specified 100, 100, 4. This indicates the color value can either be specified using the color code or using the color name. If you are giving the color name, remember to give it in full capital letters. Now, how will you know that how many colors do your system has, or which color has which code? To know all these things, simply type the word colors on your programming editor screen. After typing this word, when you will right click on this word, you will reach to a help section where you can see various colors that can be displayed on your computer screen and color codes of each color. Okay, so put pixel is used to plot a pixel on your screen using a color. Moving on to next function, it is get pixel. Get pixel is a function which is used to get the color of a pixel. The syntax is c equal to or a variable equal to get pixel of xy. That means x and y is the position on the screen, x corresponding to a column number, y corresponding to a row number. So this function indicates get the color of the pixel which is at column x and is at row y. So once the color of the pixel is retrieved, the color code is to be stored in an integer variable. I will give an example. If I am giving like this, how will it work? Get pixel will get the color of the pixel at position 100, 100 and the color code is stored in the variable C. Clear? So these are some of the important functions. So the remaining functions will be dealt in next session.